This lesson is going to cover kind of a continuation of acid-base reactions. We're going to be talking about titrations. So we're just going to look at the steps to perform a titration, talk about something called an equivalence point, and then again, the purpose of a titration is to determine the molarity of an unknown substance. And so the last thing we'll do is practice some calculations. So the purpose of titration is to determine the concentration, or you might also see it written as, remember concentration, we'll see it written as the molarity of an unknown substance. And the way that we do that is we react it with a substance of a known concentration. So let's go into that a little bit more. So acid-base titrations take advantage of a concept called neutralization. Neutralization is just a reaction where you combine an acid and a base, and it produces a salt and water. And remember, when we say salt, we aren't necessarily only talking about NaCl, even though that's what we call salt because that's table salt. A salt is any kind of compound that has a positive cation bonded to a negative anion. Okay, usually it's a metal and a nonmetal. So the way that a neutralization reaction occurs is, for example, here is my base, my sodium hydroxide, and I'm combining it with my acid, HCl. When that happens, you can see that the sodium and the hydrogen, because those are both positive, it's a double replacement reaction, and so those two elements are going to swap places. When that happens, I now have NaCl bonded together, and then I have hydrogen bonded with the hydroxide ion. Well, HOH is the same thing as water, H2O. So you can see now I have my two final products, my salt and water. So remember, when we're talking about acids and bases, we can talk about pH. And we know that the pH of a base is greater, pH is greater than 7, and the pH of an acid is less than 7. Okay, so when we look at our products, we have some type of salt and water. The reason we call it a neutralization reaction is we no longer have an acid or a base. We're basically just left with water, whose pH equals 7, which is neutral. So when we're setting up a titration, there's a few things that a few terms that we want to kind of go over or make sure that we understand. So in the top, you can see we have something called a burette. This is the kind of tall, skinny, graduated cylinder-looking glassware. It's called a burette. And the purpose of a burette is that it can drop things into like acid or a base in a dropwise fashion. So we can add to our unknown substance down in the bottom our solution in this kind of dropwise fashion. What we have up in our burette is what we call the titrant. Okay. This is what we know. This is our known, concentration. Okay. In the bottom, we have our Erlenmeyer flask. Okay, and then the solution that we have in that we call the analyte. This is our unknown, or our solution with an unknown concentration. So remember, the whole point of a titration is that we can kind of determine what is the concentration of our analyte. So as we are, once we kind of get everything set up, we have a graph where we've plotted the volume of our titrant. So that's up here. And then we have the pH of our solution. Okay, and so that's going to be like our total solution down here in the bottom as we're adding our base. As you can see, what we start off with, an acidic solution down here in the bottom, HCl. Okay, as we are adding our base in a dropwise fashion, as we start to add our base, we can see that the pH starts to rise, and then we kind of reach this point where it rises very quickly. Once we get to this equivalence point, this is where the number of moles of our acid equals the number of moles of our base. This is kind of that point where our pH, you can see, is going to be right at 7. So it's right at the point where we've reached that neutral solution. Our number of moles is equal for our base and our acid. So this is just an example of if we were, how you could see the pH changing in this first graph. This would be if our, like what we were saying, we were adding a base because we didn't know the molarity of an acid. This graph on the right would be if we didn't know the molarity of a base and we were adding an acid to it. It was just the scenario swapped. But you can see it's the same concept. We're still looking for this equivalence point where our pH is going to equal 7. Okay. And then like we said earlier, our equivalence point, okay, is just the point where the number of moles of our acid is equal to the number of moles of our base. And so if we're sitting in the lab and we're combining these two solutions, you may be asking yourself, well, how am I going to know when I get to this point? Like if I'm just adding them together, how do I know, how much am I going to add? So this is our flask, and what we use is we use something called an indicator. This indicator that turns pink is called phenolphthalein, and it is clear when you have an acid. So I've added it to the flask when the acid is in there, and then what happens is as you are adding your base, once it starts, it's clear with the base. Sorry, got it backwards. So it's clear when it's a basic solution. Once I kind of start adding that acid, once I get to the point where I'm really close to that equivalence point, I'm going to start seeing these flashes of pink like this. It's really pale pink. Once my solution turns a very pale pink, I know that I'm approaching turning the solution towards an acid. So when it's pink, it's an acid. Okay. So once I reach this little light pink color, that means I've found my equivalence point. If I get this really dark pink color, basically now I have just a full-on acid solution, okay? And I don't know how much more acid I have than base, so I've kind of passed that point. That would be like, I'm somewhere, I've kind of added too much past this equivalence point. So I want to wait till I get just a flash of light pink. And it'll stay pink. It'll kind of stay this color. You'll start with getting little flashes, and then once it just kind of stays that very, very light pink, that's when you know you're done and you've reached the equivalence point. Okay, so once we've reached our equivalence point, well, how do we determine our concentration of our unknown? So we're going to use this formula that we have seen before when we were talking about dilutions, where we had the M1, V1, M2, V2. This one is very similar, except for we're talking about the molarity and the volume of our acid and the molarity and volume of our base. Okay, so again, M is molarity, and then the V is the volume. Okay. So let's do a practice calculation here. So I have a setup. I have a sodium hydroxide as my base, as the titrant, and I have HCl as my acid. Okay. And this time it's saying, what's the volume of 0.1 molar sodium hydroxide, NaOH, needed to titrate 10 milliliters of 0.1 molar HCl. So all I have to do is plug in my formula. So I know I'm going to use, this is the formula from above. So let's look at my base. I'm given a volume. Nope. I'm just given a molarity for my base, sorry. So that would be 0.100. And then I'm looking for the volume. And then for my acid, there's my volume. And then here is my molarity. So I'm just going to plug that into my calculator. So 0.1 times 10. So that's 1 equals 0.100. And then if I divide by 0.100, in order to get the volume by itself, I end up with 10 milliliters. Okay, so that's saying that if I need to add 10 milliliters of this base in order to reach my equivalence point. Okay, let's look at another calculation here. Okay, so this one, it's saying determine the concentration of our unknown hydrochloric acid if it took 100 milliliters of our titrant. So here's my formula. Okay, so let's determine the 50 milliliters of my acid. So remember, I'm looking for my concentration. So I'm looking for the molarity. And I have 50 milliliters. And then the base, my molarity is 0.3. And my volume is 100. So when I solve, and 0.3 times 100 is just 30. Divide by the 50. And my molarity of my acid is 0.6 molar. Okay, so it's very similar to the formula that we've used before. This time you're just looking at acids and bases. And that's pretty much all there is to it. You can skip number 3. That's pre-AP only, so you do not have to do that one.